Hello and welcome. In this video we want to do some more questions about limits at infinity. The first question is find the limit of 2 radical x plus 5 over radical x minus 7 as x approaches infinity. If you remember from previous video, when we have fraction form expressions or rational functions, for finding limit of those type of functions at infinity, x approaches infinity, for finding these type of limits, we divide numerator and denominator by highest degree of denominator. So here we look at the denominator. In the denominator we have x to the 1/2. Attention, radical x is x to the 1/2. We can write it in the power form as x to the 1/2. And the other term is -7, which has no variable x. So in the denominator, the highest degree of x is x to the 1/2 or radical x. So for finding this limit, we can divide numerator and denominator by radical x or x to the 1/2. Then the limit would be like this: 2 radical x over radical x. We divide every term in numerator and every term in denominator by radical x. Now if we simplify the fractions, 2 radical x over radical x is 2, 5 over radical x. Radical x over radical x is 1 minus 7 over radical x as x approaches infinity. Now attention to the two fractions 5 over radical x and 7 over radical x. When x approaches infinity, the limit of these fractions is 0. Limit of 5 over radical x when x approaches infinity is 0, and limit of 7 over radical x when x approaches infinity is also 0. Probably you remember that limit of any number over x to any positive power, limit of such expressions, if x approaches infinity is 0. It doesn't matter what is the power of x. It can be 1, 2, 1/2, 2/3. When we have a number over something that approaches infinity, attention here, x approaches infinity, limit of this type is 0. And so the value of this limit is 2 over 1 or simply 2. But let me show you the shortcut for finding this limit. If you remember from previous video, for finding limits of functions at infinity, simply we can keep only the terms in the numerator and in the denominator that are dominant, which means that they are greater or infinitely greater compared to other terms. Look at this limit here. In numerator we have 2 radical x and 5. Because x approaches infinity, 5 compared to 2 radical x can be ignored. It's nothing because x goes to infinity and 2 radical x approaches infinity, but 5 is a constant. Also in the denominator, 7 compared to radical x is nothing. So based on this idea, if we want to find this limit, let me rewrite the question again here. 2 radical x plus 5 over radical x minus 7 as x approaches infinity. If we keep only the dominant terms, the significant terms in numerator, and in denominator we have this. Now 2 radical x over radical x is 2. As you can see, the answers are the same. But of course this way is shorter. But if you have to show your work for such questions, you have to use the first method. But if you look for the answers Of course, the shortcut method is easier. Let me show you another example. Now look at this example. What is limit of radical x to the 2 plus 6x minus x as x approaches infinity? If you pay attention, this limit is in the form of infinity minus infinity. When x approaches infinity, limit of this radical is infinity, and x goes to infinity, so it is also infinity. So this limit is in the form of infinity minus infinity, which is an indeterminate form. For finding this limit, based on the format of the expression inside the bracket, maybe you can guess that you have to multiply this expression by its conjugate. And where this idea comes from? Because if you remember, in limits, when we have radicals, usually we do this. So for finding this limit, we multiply the numerator and denominator by the conjugate of the expression in the bracket. The conjugate of radical x to the 2 plus 6x minus x is radical x2 plus 6x plus x over same expression in the denominator. And we know that we have to multiply the numerator and denominator by same thing. By doing this, we can get rid of the radical in the numerator. If we multiply this by its conjugate, we would have x to the 2 plus 6x minus x to the 2. For the first term, radical goes away, and for the second term, we have to raise it to the 2, so it would be x to the 2. And in the denominator, we just copy the denominator. So in the denominator, simply we have radical x to the 2 plus 6x plus x. Simplify the numerator, x to the 2 with x to the 2 cancels, and in the numerator we only have 6x over the radical x to the 2 plus 6x plus x. Let me simplify it here. x2 with x2 cancels, and only 6x remains in numerator. Now we have this limit, which is in a fraction form. And you remember that for finding these type of limits, we divide numerator and denominator by highest degree of denominator. But what is the highest degree of denominator? Here, basically, we have x to the 1. But what is the degree of x here? Is this really x to the 2? Of course, 6x can be ignored because x to the 2 is the term with higher degree. So ignore that for a moment. We have x to the 2, but it is x to the 2 inside the radical. And we know that when x to the 2 is inside the radical, it's not actually x to the 2. It is basically x to the 1, because the power 2 and radical can be cancelled, but when it is positive, of course, if x is positive. So basically, the highest degree of denominator is only x to the 1. So we are going to divide numerator and denominator by x to the 1. So for finding this limit, we divide everything, every term in numerator and every term in denominator by x. So we have this x to the 2 plus 6x over x plus x over x. But focus on here, how we can really divide this radical by x. If you remember from previous video, I explained this in detail, that x always can be written as radical x to the 2, but when x is positive. And because in this limit, x approaches infinity, which is positive, so x is a positive variable, we can use this. So we can replace x with radical x to the 2. And why we are doing so? Because we want to divide this radical by x, and to do so, I prefer to replace x here with radical x to the 2. So I am going to replace it with radical x to the 2. And again, don't forget radical x to the 2 is x, but I prefer to put radical x to the 2 because it makes the division of the term in numerator by this easier. Now we have a radical over another radical. Probably you remember this property of radicals, which you can write radical a over radical b as a big radical of a over b. Based on this rule, what we can do here? We can simply make these two separate radical a big radical. Let me do it here. I am going to write a big radical, and I'm going to put both of the expression on the same radical. Now we are ready to simplify the numerator and denominator. In numerator we have 6. Look at here. X to the 2 over x to the 2 is 1. So 1 plus 6x over x to the 2. 6x over x to the 2 can be written as 6 over x. And x over x here is 1. Now, because x approaches infinity, limit of 6 over x when x approaches infinity is 0. And so, this limit equals to 6 over radical 1 plus 1. Radical 1 is 1 plus 1 is 2. 6 over 2 is 3. So, the limit of radical x to the 2 plus 6x minus x when x approaches infinity equals 3. Now, look at this example. We want to find limit of radical x to the 2 plus ax minus radical x to the 2 plus bx when x approaches negative infinity. This example is similar to the previous question that we did, but attention, here x approaches negative infinity. The idea is the same. We want to multiply the expression in the bracket by its conjugate to get rid of their radicals. So we are going to multiply this by radical x to the 2 plus ax plus radical x2 plus bx, and in the denominator same thing. So we have this and radical x2 plus bx. Then by doing this, in numerator we have only x to the 2 plus ax minus bracket x to the 2 plus bx. By applying that negative in the x to the 2 plus bx, it would be negative x2 minus bx. Don't forget, the negative would be for both of the terms, so it's negative x2 minus bx all over radical x2 plus ax plus radical x2 plus bx. And attention, I forgot to tell you this at the beginning before I do this, that this limit is infinity minus infinity. Because if it was infinity plus infinity, the limit is infinity. But when we have infinity minus infinity, it's an indeterminate form, and for finding the limit we have to do some algebraic operations. And x approaches negative infinity. Simplify numerator. If you simplify numerator, numerator would be ax minus bx, and the denominator is radical x2 plus ax plus radical x2 plus bx as x approaches negative infinity. Similar to the previous question, we are going to divide numerator and denominator by highest degree of denominator, and we know that the highest degree of denominator is x, so we divide numerator and denominator by x. If we divide every term in numerator by x and every term in denominator by x, we have, and we divide the radicals also by x. But attention, there is a difference between this question and the previous question. In the previous question, x approaches infinity, and so instead of x in the denominator, we can replace it with radical x to the 2. But if you remember, I mentioned this and I emphasized on this in the previous question, that this is a common mistake to think that x is always radical x to the 2. And you can replace x everywhere with this. No, this is wrong. This is only valid, and you can do this if x is positive or greater than or equal to 0. When x is less than 0, if you want to replace x equals negative radical x to the 2 when x is negative. So here in the denominators, we have to replace every x with negative radical x to the 2. Don't make this mistake to think radical x to the 2 is always x. Radical x to the 2 is x when x is greater than or equal to 0. When x is less than 0, radical x to the 2 is basically negative x. And so x is negative of radical x to the 2. Based on this, let's back to our question. For every x in denominator, we replace them with negative radical x to the 2. And why we are doing so? Because x approaches negative infinity, so we cannot consider x as a positive variable. X is negative. Now if we merge the radicals and make them like a single radical, we would have, let's simplify also this is a, the other one is b, and in the denominator we have negative radical x to the 2 plus ax over x to the 2, and the other one would be negative, don't forget this negative radical x to the 2 plus bx over x to the 2. If we simplify and we divide basically these terms by x to the 2, we can rewrite this as x2 over x2, which is 1. So I am going to simplify the inside of the radicals. 1 plus ax over x to the 2 is a over x. Here also x2 over x2 is 1, and bx over x2 is b over x. So we have 1 plus b over x. And x approaches negative infinity. Because x goes to infinity, limit of a over x and limit of b over x, limit of this and limit of this, when x goes to infinity is 0. So this limit equals to a minus b. This would be only negative radical 1 because this is 0. And negative radical 1 is negative 1. The other one, this one is also negative 1, which is negative 2. So the limit would be a minus b over negative 2. So the limit of radical x to the 2 plus ax minus radical x to the 2 plus bx when x approaches negative infinity is a minus b over negative 2. I hope you like this video, and if you like this video, please subscribe in my channel and see you in the next videos.